We're live.
Okay, so here we are at Ocean Point, and we are in the low wave exposure location. This is the low wave exposure transect that you're going to be looking at, and we're going to be working from low tide to high tide. And you can see here, you can already see the difference. We have no chondrus. There's no chondrus zone here. And in the low wave energy sites, that's what we find, is that there's a lot more mixing of species here. The zones are really not distinct at all. And we're standing now in an area where it's dominated by two different species of algae. One is Fucus vesiculosus, and that one is, this one you can identify because it has what I call vesicles, vesiculosus vesicles, and you can see that those are in pairs on either side of like a midrib down the frond. And on the end of these fronds, just like the other Fucus species, when it's season for them, these gamete pods will swell and they'll release their gametes into the water column on an incoming tide. And again, the gametes, that increases the chances the gametes will find each other. The other species that we have here that we haven't seen yet is Ascophyllum nodosum. Ascophyllum nodosum is a long spaghetti strand type of algae. It provides home for a bunch of snails and for other epiphytes, which means there's another organism that lives on it, so it provides a home for this other epiphyte. And these are kind of cool. They're only found in areas of low wave exposure, and that is because their holdfasts, like all the algae, they have a holdfast on the rock. Their holdfasts are really weak, so they can only be in low wave energy. So the low wave energy transect is dominated by Fucus spiralis, Fucus vesiculosus, and Ascophyllum nodosum. All of the zones are mixed. We don't have a distinct barnacle zone like we did in the other two. We do have a calothrix zone. Maybe we can walk up and look at the calothrix zone. Calothrix is super slippery, but any of the rocks that look black, like this is calothrix, the big green algae. So this is really flat compared to the other transects we've looked at. And again, a flat slope is indicative of a low wave energy site. So can you see the calothrix zone up there? It's where the rockweed stops. And we get just a little bit of the blue-green algae at the top of the transect. Not nearly as high as in the high wave energy and in the intermediate wave energy. So the calothrix zone stops right around here. So there's a very small splash zone here.